The myth that data scientists are one in a million unicorns that can do everything you can't and more has long been busted. But did you know that that engineers also make really good data scientists? My name is Harmen, and in my time at bol.com, I've been a software engineer, a machine learning engineer, and a data scientist. So I feel like I have something to say about how data science and engineering are actually much closer than you would expect. I have 10 minutes and 10 reasons, so let's get to it. The first reason is curiosity. Let me show you a resume of a random engineer I found. And look at how many programming languages there are on there. And that's with a good reason. And it's not to brag. It's because this person really believed that all these programming languages have something unique to offer. And he wanted to find out, hey, how do they work? How do they work under the hood? And it's this curiosity that also drives data scientists to do the things that they do. They are looking for this moment of how does this work? That doesn't make sense. This eureka hormone drives both data scientists and engineers. The good thing about becoming a data scientist is that my resume became a lot easier. So this unicorn that was busted, it actually turns out to be 3 different roles. First off, you have the parakeet data scientists that fly around the company and sing songs about all the data they find and spot opportunities, and they make colorful graphs about the data they find. Then you have the narwhal data scientists who will take deep dives into the data, who will find the iceberg under the peak, and who will poke their models to tweak them to be perfect. And then you have the donkeys, the stubborn ones that ensure good data quality, the ones that take a lot of data from A to B. And it's these donkeys or data engineers that are actually much more sought after than data scientists. And there's a good reason for that. A data scientist needs good data to be able to function properly. Without that, they're virtually useless. But a data engineer ensures good data. So a data engineer is a requirement for a data scientist. But a data engineer by themselves is also useful for a company if they ensure good data quality. So it's this working together that's important. So when the parakeet and the narwhal start working on their models, their algorithms, it's a very iterative process. So the parakeet will fly around, try out different things. Most of them will fail because it's just so unknown what will happen based on the data, because the data is unknown, because the use case used most of the time is unknown. But once we find something that's useful, the narwhal will start tweaking it and improving it bit by bit. And this might sound very familiar to you. It's something you probably have been doing for a long time already. It's this agile process of continuously improving, continuously checking, hey, is the stuff that I built, is it still doing what I wanted to do? Did it improve, or should we throw it away? And to be able to see if it works or not, or to be able to spot these opportunities, you need to have a great eye for detail. You need to, for example, be able to spot the one mistake in a huge code base of code. And I see some of you already screaming at your screen, watch out for that semicolon, it's going to screw up your if statement. And that without highlighting. You have that eye for detail. You can dive into your Grafana graphs to find the one reason why your CPU is being overused, or why something is going wrong. You can feel your systems going. You can see the matrix through this data, and that's how data scientists work as well. They dig through the data and try to find the right answer. Now, there's a crisis in data science land, and it's called the reproducibility crisis. Let me share 3 examples of what this entails. When you're a narwhal data scientist, you dive into a rabbit hole and you're tweaking, but you just can't find the right model. What do? Or when you build a really nice model, but someone else wants to verify it, how do they ensure that they get the same model? or you deployed something to production and it works fine, but after a couple of weeks, due to data drift, it starts performing much worse. What do? Well, it's obvious to you maybe. You just git reset hard, or you check out their feature branch, or you roll back the deployment. But these are all things that data scientists are not necessarily familiar with when they come from academia. So they need your help to manage their system and make their work reproducible. And in fact, all the code that they produce is a vital, but essentially it's just a small part of a bigger application. All the machine learning code requires to be monitored so that we can be sure that it works properly. The data needs to be collected and it just needs to scale up and down depending on the load. So we need all these systems around it to make sure it actually integrates properly with our IT environment. And in fact, that's maybe the whole point. Data scientists can code, but they are not engineers. So similar to a UX designer, they know how things should work, but they can't implement it themselves. It's similar to a backend and a data engineer working together to build one system using both of their expertises, or security and platform engineers finding that right balance between all our needs. And it's really similar to working together with any other discipline, like a business analyst or your product owner, with your architect and with your testers and your domain experts. And yes, if you have them in your team, your data scientists. So maybe this is the whole point of this talk, is that in the end, it's all about working together with data scientists. They can do things that you can't, but you can also really help them make sure that what they do brings value. Because if they can't get it on production, it doesn't bring any value to the company. But there are a few more things that give us the edge. Programmers in the bottom graph type way faster than normal human beings, like data scientists. And in the iterative process, the faster you can code, the better it works. And this is, of course, because of all the Git tricks that we learned. We want to minimize the amount of space between our brains and the work that we produce. About testing. Testing is really hard. But testing machine learning models is actually harder because you can't break them down into small, manageable parts. You can't write unit tests for them. Most of the time, you don't know what the output is going to be. But since you've all probably tested spaghetti code, you know tricks to get around it, end-to-end tests, statistical tests to make sure that your work still works, even though it's nearly untestable. And last but not least, A/B testing. There's this rule, this law that states if a metric becomes a target, it ceases to be a good metric. And this goes the same way for data science. It's called overfitting in data science, and it's when you focus too much on a small part of your data, ignoring everything else, making it worse. You see the same thing in A/B testing. So you always need to A/B test, and this is second nature to us. We always want to verify with our customers, hey, is what we built what we actually wanted? So if I should summarize this talk in one sentence, it's if it ain't on pro, it don't bring in the dough. Thank you very much.